Physics Part 15. However, it is worth thinking about how to compare the calibration of one instrument against another. Even if this is a check you will very seldom make in a planning design question, you might be asked to suggest a method of calibration. Generally, it is easy to compare the calibration of different instruments, but not so easy to determine which of the two instruments giving different readings is correct. On the pages that follow, we shall spend most time on the method for measuring length, because length measuring instruments of the several different types will be available in your laboratory. Methods of measuring length. The meter rule. The figure shows zero error with the meter rule. The simplest length measuring instrument to be found in your laboratory is the meter or half meter rule. It has the great advantage of being cheap, convenient, and simple to use. A relatively unskilled student should have no difficulty in taking a reading with an uncertainly 0.5 mm. However, you should be aware of three possible sources of error in using a meter rule. The first may arise if the end of the rule is worn and giving rise to a zero error. For this reason, it is bad practice to place the zero end of the rule against one end of the object to be measured and to take the reading at the other end. You should place the object against the rule so that a reading is made at each end of the object. The length of the object is then obtained by subtraction of the two readings. A zero error like this is a systematic error. And sometimes it happens even if we are trying to get it on our own, we do make some mistakes. Because it is involved every time a reading is taken from zero end of the rule. A more detailed explanation of the systematic error will be found in our section 2.2. In general, the zero reading of any instrument may be subject to an error. We shall meet this type of error again in the micrometer screw gauge and in the ammeter. The calibration of the meter rule may give rise to another systematic error. Because the markings are incorrect, try comparing the 30 centimeter graduated length of one plastic rule with the same nominal length of another. You are quite likely to find a discrepancy of 1 or 2 millimeters. One of the reasons why wooden and plastic meters rules are cheap is that the manufacturer does not claim any great accuracy for the scale marking. The calibration may be checked by laying the ruler alongside a more accurate rule, such as an engineer's steel rule with a plastic rule. You will find at once that the engraved marks on the steel ruler are much finer than the pressed marks on the rule has to be paid for. A 1 meter steel rule is many times more expensive than a plastic meter rule. Another source of error with the meter rule is the parallax error. If the object to be measured is not on the same level as the graduated surface of the rule, the angle at which the scale is viewed will affect the result as shown in the figure. This is a random error, you can see it in this section, because the angle of the view may be different for different readings. It may be reduced by arranging rules so that there is no gap between the scale and the object. The parallax error is important in reading any instrument in which a needle moves over a scale. A rather sophisticated way of eliminating parallax error is to place a mirror alongside the scale. When needle and scale are viewed directly, the needle and its image in the mirror coincide. This ensures that the scale reading is always taken at the same viewing angle.